Hey Daniel.
Yeah, Lisa, the pizza. Come sit. What are you here for?
I'm here to ask you if you're joining me to meet Miss Chalet for the extra classes.
Oh, is this for the study of stacks and queues and data structures?
Yeah. Are you joining me?
Oh yes, yes.
Okay, then let's leave from here.
Lisa. This is Miss Chalet's room.
Okay then, come let's go in. Good morning Lisa and Daniel. Good morning Miss Chalet.
Good morning, teacher.
How are you both?
We're fine, Miss Chalet. How about you?
I am fine dears. Are you ready for today's class? Yes Miss Chalet.
Yes!
Okay then, let's start with our topic. Today we are gonna learn about the working of stacks and queues and data structures using C++. Before that, what do you know about stacks and queues in general? Stack and queue are examples of non-primitive data structures.
A stack follows last in, first out, order. Whereas queue follows first in, first out, order for storing elements.
Yeah, you're right. So basically, stacks is a linear data structures, like arrays and linked lists. Different operations are allowed to take place anywhere in linked lists and arrays, but when we talk about stacks, operations take place only at one end, that is, the top of the stack. Top value is incremented by 1 for push operation, and top value is decremented by 1 for pop operation. It follows a specific order, that is, LIFO, last in, first out, principle. There are many real-life examples of a stack. Look at this set of books arranged one by one. This is arranged as a stack.
What is the value of top when the stack is empty?
When the stack is empty, top value equals to -1. Okay.
Yeah, okay.
Now, moving ahead, we shall understand the basic operations on stack. So the basic operations on stacks are push and pop. Now, let us discuss each one of them in a detailed way. First one is the push operation. So the push operation is the mechanism of inserting a new data element onto the stack. Push operation involves different steps. First, we check if the stack is full or not. If the stack is full, print stack full and exit. And if the stack is not full, then increment top by 1. Add data elements to the stack where the top is pointing, and the data is successfully added. Miss Chalet, is it compulsory to fill the stack completely? No, it is not compulsory, but be aware that the stack does not overflow. Now, followed by the push operation, is the pop operation. So, pop operation is a mechanism of eliminating or deleting a data element from the existing stack. Pop operation performs some steps to remove an element from the stack. Firstly, we check if the stack is empty or not. If the stack is empty, then print stack empty and exit. If the stack is not empty, approach the data element at which the top is pointing. Then decrease top by 1, and deletion is successful. Did you understand the topics taken till now? Yes. Okay then, let's continue. So, stacks are non-primitive linear data structures, in which insertion and deletion takes place at only one end, that is, the top of the stack. Stacks does not have any types. Now, let's learn about queues. Before going to its definition, let's look into a real-life example of queues to understand it clearly. Most relevant example of a queue is a movie ticket counter. In the movie ticket counter, you must have observed that both of its ends are open, and no one can enter in between the queue. Obviously, the person who enters first will get the ticket first, and the person who enters last will get the ticket last. This gives the clear example that queues follows FIFO principle, that is, first in, first out order. Basically, they are defined as a linear collection of different data types that allow insertion at one end and deletion at another end. Unlike any other data structures, the queue ends remain open. The end at which insertion takes place is called rear, and the end at which deletion takes place is called front. If you consider the left end as front, then the right end will be considered as rear and vice versa. Unlike arrays and linked lists, elements in the queue cannot be operated from their respective locations. Here, theta can only be operated from the front or rear ends of the queue. Now, let's go through the different operations of queue. Insertion operation is called in queue operation, in which elements are added to the queue. Deletion operation is called a queue operation, in which elements are deleted. Now, let's know what is the algorithm for perform insertion and deletion. In the algorithm for insertion, first we'll check if the queue is full or not, and if the queue is full, produce queue is full and exit from the function. If the queue is not full, increment rear pointer to point the next empty space. Add data element to the queue location, where the rear is pointing. And then, element is added successfully. Now, the next operation is deletion operation. The first step of this operation is to check if the queue is empty. If the queue is empty, then print queue empty and exit, and if the queue is not empty, achas the data where front is pointing. Increment front pointer to point to the next available data, and then the element is removed. I hope you understood what is queues and its different operations. Yes, we have understood, Miss Chalet. But I had a doubt. Does stacks and queues have only insertion and deletion operations?
Even I too have this doubt.
That was a nice question. Let me clear that. Not only insertion and deletion, there are many more operations taking place in both stacks and queues, but they aren't that important. You get it?
Okay. Now, we get it.
Okay then. Let's continue. Next we will discuss different types of queues at a glance. Basically, there are 4 types of queues: linear queues, circular queues, double-ended queues, and priority queues. Linear queues is a simple queue which is used very often. Circular queue is almost similar to the linear queue except that the last node of this queue is connected to the first node. Additionally, circular queue is a better version of linear queue, as it removes the drawback of insertion in the linear queue. The empty space available in a circular queue can be filled with the new element by simply incrementing the value of the rear position. A priority queue is another type of queue data structures in which each element has same priority assigned with it. The last type of queue is double-ended queue. It is a linear data structure in which insertion and deletion operations are performed from both ends. It is a generalized version of queue. Double-ended queue can also be used as stack as well as queue, as it allows insertion and deletion operations in both ends. Okay then, that's all for our topic today. Do you have any doubts?
No, Miss Chalet. The topic is clear.
Okay then, today's class has come to an end. I hope you understood everything clearly. If any doubt, you can ask me personally. I will be available. Thank you, dears. Thank you, Miss Chalet, for this wonderful session of yours.
Thank you, Miss Chalet. Now, we'll take a leave.
Bye, Lisa and Daniel.
Bye, Miss Chalet.
Bye, Miss Chalet. Today's session was wonderful, isn't it, Daniel?
Yes, Lisa. Now, it's time for us to leave.
Yes, buddy. Bye.
Bye, see you later.